So when it's just removed from the oven, the time is just 0. No time has passed yet. So the temperature when the time is 0 is just 85 e to the negative 0.1 times 0. And since e to the 0 is 1, your starting temp is just right there, that 85 degrees Celsius. And that's all that one is. And then this one, instead of giving us the time, they gave us the temperature. So we're just going to fill in the temperature with 25 and solve for the time it takes to do that. So we like it when they give us an equation, right? If they give us an equation, they're either going to give us one of the parts of that equation, either the time or the temperature, and we just solve for the other one. So when you go to solve, get the e alone by dividing both sides by 85. So 25 over 85 equals e to the negative 0.1 t. And then to undo the e, take the ln of both sides, so that you'll get the ln of 25 over 85 equals, and then those will basically cancel to get you negative 0.1 t. And then to get the t alone, just undo that final multiplication by dividing. So divide by the negative 0.1, you'll get your t. If you punch this in on a calculator, you'll get about 12.2, and I forgot what units were in, hours, minutes, something. So yeah, not too bad. Plug and chug. Okay, so we're just going to begin solving. You're going to undo the multiplication first to get this exponential guy alone. So if I divide both sides by 4.16, I'm going to get 0.35 to the x equals whatever 44 divided by 4.16 is. And now I can start to undo the exponent by taking the log of both sides. So just sneak a log in over here, sneak a log in over there, taking the log of both sides, which allows me to pop that x down to the front. So x log 0.35 equals the log of 44 divided by 4.16. And now I can just undo this multiplication. X is being multiplied by whatever the log of 0.35 is by dividing by whatever the log of 0.35 is. And then you can just punch this mess in on your calculator. So this isn't an exact answer. The only thing you'd want to do is maybe simplify that. But if they just want a decimal, it's just negative 2.2467 something. I didn't see how many decimals they want, but that's it. Okay, so this one's a fun one. Comes kind of out of the blue. There are an infinite number of solutions to this, right? We have two things we need to know, but there's only one equation, so not a lot of limitations. So this is a graph, and you could graph it, and there's an infinite number of points on that graph. So I suppose our goal might be to just solve for one of the variables and to generate a formula for the infinite solutions. And then we can play with it and kind of find some nice ones. So if I try to solve for y, let's say, I could just divide both sides by 5 to the x, and I can say that 10 to the y equals 80 divided by 5 to the x. And then if I take a log of both sides, the log of this side and the log of that side, then if I take a nice log base 10, it'll just knock that side out. So the y will equal the log of 80 divided by 5 to the x. And that'll generate an infinite number of solutions for you, right? So you could say, well, let's say if x were 0, the y could be the log of 80 divided by 5 to the 0, which is 1. So the y would be the log of 80. And so it's like, okay, fine. That would make that true, I suppose. I mean, you could check it if you put it in, right? If you checked it, you could say that 5 to the 0 is 10 to the log of 80. And 5 to the 0 is 1. 10 to the log base 10 of 80, they knock each other out. That just gives you 80, which it's supposed to. Check, right? So there's one solution. You can just keep going. If x were 1, the y would be the log of 80 over 5 to the 1. So the log of 16. So there's another solution. When x is 1, that's the log of 16. And you could plug in anything you want. You could plug in decimals or anything. I started to play to see if I could find something nice, like the log of something we knew, and this was kind of a fun game. because you want this, you want the 80 over 5 to the x to be a nice power of 10, right? If you want to find like a common answer. So you want 80 over 5 to the x equals 10 to something. And so then I was going to just try to play with and see if I can make tens. So 80 is, if I just keep dividing by 2, it's 2 times 40, which is 2 times 20, which is 2 times what have I got so far? I've got 2, 4, 8, 16, and then an extra 5 at the end. And then on the bottom I've got 5 to some power, right? Well, I kind of want all these 5s to be matched up with that 10. So, what am I trying to say? So I would kind of like for it to be, this is going to make a 10, that 2 and the 5. But I kind of want all those to make 10s too. So if I divide by 5 times 5 times 5, that'll be awesome, right? I'll have 10 times 10 times 10 times 10. This will be 10 to the 4th. So if I let that x, I need to make it be a negative 3. So if I let x equals negative 3, this will give me a nice clean solution, because 80 divided by 5 to the negative 3 is 80 times 5 to the 3rd, which does give you 10,000, which does give you, and then the log of 10,000 will be a perfect 4. So if you have the log of that for the y, that would be 4. So that's not x to the negative 3. That was supposed to be x equals negative 3. Get a little excited. So that's another one of our answers. Maybe the one they were looking for, because it's very clean. So you can check it. What did we start with? 5 to the x, 10 to the y equals 80. So 5 to the x, 10 to the y is supposed to be 80. So when we do 5 to the negative 3 and 10 to the 4th, does that really give me 80? That's 10 to the 4th divided by 5 to the 3rd. And that's 10 times 10 times 10 times 10 over 5 times 5 times 5, which is 2 times 2 times 2 times 10, which is 80. Check. So anyway, yeah, I'm not exactly sure what the problem wanted, because there are, like we said, an infinite number of solutions. This guy, any x you like. And then this is a nice clean one, and there are more clean ones, I'm sure, if you just keep playing. And then you could give a general answer just by saying infinite number of answers such that y equals the log of 80 divided by 5 to the x. There you go.